Hi, in this video I'm going to talk about recursion. I learned recursion the hard way by learning Scheme. I read the book, The Little Schemer, which is a really fun and very unconventional book, but I highly recommend it. Recursion is really fun to learn. I was really proud of myself when I finally could wrap my head around its concepts. And also, every developer runs into the problem of having to traverse a tree or graph in their career at some point. I'm going to break down what recursion is, how you would approach writing a recursive function. I'm going to talk about tail call optimization, and I'm going to give an example on how to traverse a tree, and finally I have a challenge. First, what is recursion? In the most basic terms, recursion is a loop. It's commonly defined as a function that calls itself until it doesn't. Just like a while loop, you have to specify in the condition of the while loop when it should stop looping to prevent an infinite loop. It's ultimately defined as splitting a problem into smaller versions of that same problem. Let me show you what that means. Now it's important to realize any loop can be written recursively. It's not true the other way around. Not every recursive problem can be solved with a for or while loop. It's actually more powerful. So I've got a very basic for loop over here. Let's solve it recursively. First, we need a function. We need to call that function. And the function does a loop call. And it also, of course, stops when the condition isn't true anymore. So let's check for not true anymore, and let's return. And it's as simple as that. We do the same console log action. We check for when this is true, and if not, we return. And we add a number every time. So if I run this, I now have the same implementation twice. Now this basic example already has the three basic elements of every recursive function. We run the operation, we do the self call, the recursive call, and at some point we break out the loop. Next, let's take a look at how you would actually solve problems recursively when starting from scratch. So let's implement a range function. The range function should take a number as input. I want a range from 1 to 10, and then it should output an array with the numbers 1 to 10. So we're gonna take a function which is going to take a few arguments. We need a min and a max. And as an output, I would expect, if I give it 1 to 5, I would expect these numbers. So how would I achieve this? I need to solve for the base case, and I need to solve for the recursive case. The smallest problem I can think of is just generating a single number. So let's first introduce some test cases. If I call range with 0 to 0, I would expect a 0. And let's introduce some new lines so that I have an easy time at this. If I call it with 1 to 5, or if I call it with 0 to 1. So the base case would be solving the simplest problem, with it, which is just the min. This would already solve my first case, but it would of course only solve the base case. So let's test for that. Let's actually add some log statements so that we have a clue on what's happening if our examples become bigger. This is our base case. These were our inputs. And now if we run it, we can see the base case is 0, 0, it was triggered, inputs is 0. So how can we expand our solution to include the recursive case? At this point, we'll need an array. We need to store our values in the array. We need to append to that array each recursive call. And in functional programming, we don't mutate our variables in loops. We need a different way to store our variables. Let's create another function for this. It's very common in recursive programming to use an argument for this. Let's call this our accumulator. I'm going to start empty. Going to move our base case. And we can start to think of a recursive case. So let's increase it by 1. And let's write this to be a concat so that the append is actually happening to the accumulator that we have. So we're still doing the min, and we can probably copy that over here. Let's see if that works. So I forgot to return. And there we go. Let's update our log statement so that we can see what's actually happening here. Let's add one for the recursive case as well. That's over here. And let's look at the logs now. Now, if we're okay with having a default argument in the top level function, then we can actually get rid of the inner function. Let's rename this to range, and it should still work. It does. So as you can see, these log statements are very useful. I highly recommend you're writing these kind of log statements, separating the base case and the recursive case while developing or debugging recursive functions. It will increase your understanding of what's happening. Let's look at another example. Here you can see the same problem solved in 2 different looping directions. One is increasing start and the other one is decreasing end. Let's look at how this actually works. So for this I'm gonna add the log statements again. This is the base case. Here we have start, end. And here we have the recursive. Okay, oh. The first implementation starts with an array with only one item with the start variable in there, and it does the recursive call adding 1 to start. And you can see that you go from 5, 6, 7. The first argument, which is the start argument, is the one that's increasing. The end is staying at the static variable. And when it reaches 11, it will basically not add the 1 anymore, and it will just return the empty array, which is then used in the concat value. So it's adding an empty array to the existing array. And in the second example, you can see that decreasing the end variable is also a way to solve this. It's a very similar implementation. There's quite a few tools out there that visualize what kind of function calls and thus scopes are being created so that you can better understand what's going on. This one is in Python, but it still does the job by explaining which function calls are happening, which return values are there. And every one of these function calls actually creates a scope. This one is not in tail position. I will explain this. But after the range call, the array concat is still happening. So in here, we're looking at a JavaScript example again. The first one is not a tail call because the concat operation is happening after the recursive call. So the recursive call is not the last thing that is happening in this function. But we can actually turn this into a recursive call. In the second example, you see that this call is the last thing that's happening in this function. An example that you'll often see is that of walking a tree or a graph. Let's look at that. I've got a JSON that mimics a nested directory structure, and I've got a walk function that iterates over this tree. Walk takes a function that it calls for every node it runs into. It's like a map function, but then for a tree instead of for an array. It also takes a data structure, which it will walk. Our recursive function has 3 parts. It calls the function we pass it, which is our log function. If it detects no children, our base case is stop here. And if it does detect children, then for each of these children, it's going to walk the tree again recursively, which results in all the names that are in there are being printed. And I hope that at this point in the video, this is easier to understand. And lastly, I've got a challenge for you. If you truly want to be able to apply this knowledge, you need to practice it. You need to hone your skills. Just having the theoretical knowledge is not going to be enough to be able to apply this. What I did myself is I implemented 10 random functions from a functional programming library, like the ones you're probably familiar with, map, filter, reduce amongst them. I just implemented them myself in a recursive way. This really helped me think in terms of base cases and recursive cases and in which order I wanted to do the iteration, which is really important to drill down and wrap your head around it. And only after I've implemented these functions and more, it really clicked for me. It was actually a lot of fun to do. I highly recommend it. And that's it. I hope you've enjoyed this. If you have any thoughts or requests for things you'd like to see, leave a comment and subscribe. Thank you very much for watching.